So we're going to graph this quadratic equation that's in standard form. It's our job to look at it and go, oh yeah, this is in standard form. And because of that, we can find its vertex, right? So our goal is to first find the vertex. And because this is in standard form, we know the x-coordinate of the vertex will be negative b over 2a. And then the y-coordinate will always be f of negative b over 2a. These are just facts that you just need to have or have access to. So our job is to look at this equation and figure out what all of the coefficients are, a, b, and c. First of all, we should look at this and go, oh, a is negative 1, because there's a 1 there that we rarely, if ever, write. Okay? Our job is to look at b and realize that b is negative 6, and we don't need to worry about c, but I guess in the future we will, so c is negative 4. So our vertex is negative b, so negative 6 over 2 times negative 1. And f of, I'm going to start simplifying this, negative 6, that's just positive 6. 2 times negative 1 is negative 2. So that is my vertex. I am going to take a moment and evaluate it and find the values of this vertex. Well, 6 over negative 2 is negative 3. And then I got to calculate f of negative 3, right? This is f of negative 3. So I got to plug in negative 3 into this. So I'm going to be very careful. I'm actually going to change colors because this is the spot most students goof up. All right, so all I did was I plugged in negative 3 for each one of these x's, and notice I have negative 3 squared, but then I'm going to be taking the opposite of it. I always like to put in my parentheses here to make sure that, that I don't forget that I'm squaring that negative. So when I do that, I get negative 3. This turns into negative 9. Negative 6 times negative 3 is positive 18, minus 4. I'm going to do one more set of evaluations. Negative 3, right? This is just our x-coordinate. This is 9 minus 4, which is 5. So I know my vertex is at negative 3, 5. So I'm going to start sketching this out. Negative 3, 5 is up here somewhere. I also know, because a is less than 0, I know that this is concave down, right? This is also a fact that I just know. Because a is less than 0, this is concave down. So I could start sketching this if I wanted to. But what I'm going to do instead is find a specific point. Right, that is the next step. We got to find a specific point. I could choose any x value I wanted, but I might as well choose an easy one. So f of 0, or choosing an x value of 0, is the easiest thing to do. So I'm going to choose to find 0, f of 0. And the reason why that one's easy is 0, plugging in 0 into this. 0 squared is 0. Negative 6 times 0 is 0. So it's 0, negative 4. It's just going to be it's going to be 0, the constant term when it's in standard form. So I got to come over here and find 0 and negative 4. I'm going to be relatively to scale. Negative 4 goes about there. Probably, maybe a little bit lower. Anyway, so it goes about there. And then I can find the symmetric point. I should have labeled this. This is the other point. So I'm going to find the symmetric point. Well, 3 units to the right of negative 3, this is negative 4. So 3 units to the left of negative 3, so at negative 6, this function also has a value of negative 4. It's not quite symmetric, but that is the symmetric point. Negative 6, negative 4. So then I can sketch my curve. There it is. So just a quick review. Your first job is to go standard form. Therefore, I know that this is the form of my vertex, negative b over 2a. I find the x-coordinate, I find the y-coordinate, I can plot those. I know that it is concave down because of that negative a is less than 0. If a was greater than 0, it would be concave up. And then I find another point. And notice I find another point, and it confirms that this thing must be concave down. The fact that it was below my vertex. If I got positive here, I would have expected to find that above, and if I didn't, I know I've made a mistake and I got to double check my work. And then, so I found my other point, and then I should be able to find my symmetric point from there. So my symmetric point, if I went 3 units to the right of my vertex, then my symmetric point is 3 units to the left, and vice versa if it's somewhere else. Anyway, I hope that's helpful.